Well, we have this existing layout, and the idea of the electrical section is to split this array in small sections, and then you can assign inverters, create the string conductors, and connections from each section to the point of interconnection. So the first step is to find the point of interconnection. You have to give to the software the dimensions and just select the location for that. Then you can split the array automatically or manually. In this case, I will do manually. If you do it automatically, you only have to say, hey, I need this quantity of exceptions. But if you do it manually, you only need to give a name to the exception and select the tables that you want for that exception. The software will change the color of the tables just to see, just it's more easy to see the sections with a different color, and you can repeat the same process for the whole array. Then you can insert inverters automatically manually. In this case, I will do it automatically. I only have to give the dimensions of the inverter and how many inverters I want for this section. In this case, I want 6. And the software it will be splitting this section in 6 small pieces and assigning one inverter to each one. I can do the same thing for the rest of sections. Then I can insert string conductors. You can see there are conductors from the tables to each inverter and the same for each section. Then you can insert connections to a pointer of interconnection. And basically, the idea is to have one AC combiner for each section, and then you have this wire going into a point of interconnection. And the idea of this is to give you a bill of materials with the wire quantities. In this case, the units is inches because my drawing is in inches, but you can change the units at the beginning to fit. And you will have PV wires, distance from the inverters to the AC combiner, and basically the distance for the AC combiner to the point of interconnection.